definition, let P be a partition of closed interval AB. We define SPF alpha is equal to summation I going from 1 to n f of ti delta alpha I, where ti belongs to closed interval xi minus 1 xi, where f is real bounded function on closed interval AB and alpha is increasing on closed interval AB. Then, if I take the limit mu p tends to 0 on SPF alpha, then this will be equal to A. Now what is mu p? Mu p is mesh of P, right? Which means for every partition P of closed interval AB with mu p less than delta and for all the choices of Ti belonging to xi minus 1 xi, my limit if mu p tending to 0 on SPF alpha, then this will be equal to A, right? Now here, if you look at here, this is your interval, closed interval from A to B, and this Ti is belonging to xi minus 1 xi closed interval. Fine. Now this mu p is equal to maximum of delta xi, where I is from 1 to n. And what is delta xi? It is xi minus 1. The maximum of among all the delta xi, that is your mu p, right? And if limit this mu p is tending to 0 on SPF alpha, then this will give me A, right? So A exists. Let's prove this statement. If limit mu p tends to 0, SPF alpha exists, then f is Riemann integral. That means if I take my limit mu p tends to 0 on SPF alpha, if this limit exists, then I say that f is Riemann integral. And what is this limit? This limit is equal to A to B f of d alpha integral. Fine. So let's start with the proof. Let limit, what is given to us, mu p tends to 0, SPF alpha, this limit is existing. So let this mu p tends to 0 on SPF alpha, let this limit is equal to, let's say, A, right? Then using the definition just now what we have read, then for every epsilon positive, there exists delta positive such that every partition P of closed interval AB with this mu p less than delta and for all choices of Ti belonging to this closed interval xi minus 1 xi, we have mod of SPF alpha minus A. This mod is less than epsilon, but I am taking here epsilon by 2. That is, according to the definition of this mod, that is A minus epsilon by 2 is strictly less than SPF alpha and it is less than A plus epsilon by 2. Let's say that this P is such a partition of closed interval AB. So let P be one such partition of closed interval AB. Now taking the supremum and infimum on SPF alpha, right, for all the choices of Ti. So from 1 we get, A minus epsilon by 2. This is less than, LPF alpha, very good. This is less than equal to UPF alpha. And this is strictly less than A plus epsilon by 2. This implies now the difference of the middle ones is strictly less than difference of the last ones, which is equal to epsilon. So we get UPF alpha minus LPF alpha strictly less than this epsilon, which means f is Riemann integral. So this implies, because this is a result, So this implies f is Riemann integral on closed interval AB. Again, since now we know that this from 1 only, FPF alpha is, I know that this is less than equal to SPF alpha, and A to B FD alpha, because it is Riemann integral, so lower Riemann integral is equal to upper Riemann integral is equal to this integral. This is strictly less than UPF alpha. Very fine. Can I write like this? Yes, of course. Because I need this integral in the result, so that's why I have taken this. Now again, taking the difference of the middle ones and the last ones, let's say, therefore, if I take the mode of SPF alpha minus this integral A to B FD alpha, because I know that difference of UPF alpha minus LPF alpha, this difference will be less than epsilon. That's why taking this difference and then mode, this is less than equal to UPF alpha minus LPF alpha, and this is, I know that, less than epsilon, which means this mode SPF alpha minus this integral A to B FD alpha mode is less than epsilon. Right? Now since for every epsilon positive there exists delta positive such that this mode is strictly less than epsilon. This is for every epsilon, right? So for every partition, again I have to mention this P, for every partition P of closed interval AB with, of course, I have to mention this mu P less than delta because I have to mention the limit over here, and for all choices of Ti belonging to xi minus 1 xi, right? So therefore this limit mu P tending to 0, this is by definition I am writing, so limit mu P tending to 0, SPF alpha is equal to this integral A to B FD alpha. So this is from the definition, hence the result.